All right, we're going to begin our study, the chapter on gases. When we're dealing with gases, there are four quantities we're going to need to keep track of. The first is pressure, which is symbolized with a capital P. Volume, we're already familiar with that, which we'll symbolize with a capital V. Temperature, which we will symbolize with a capital T. And in this chapter, and anytime we're using the gas laws, we're going to make sure we use the units of Kelvin when we're using temperature. And then we have amount of gas or moles of gas, which is abbreviated with a little n. The new unit of these, we've already covered these three, the new unit is pressure that we're going to discuss now. Pressure is defined as the force applied over an area. Because force has units of newtons and area has units of meters squared, the units of pressure will be newtons per meter squared. Now, a newton is also, 1 newton is a kilogram meter per second squared. So we could also call this unit of pressure kilogram meter per second squared, substituting in this value for newton, divided by meter squared. Of course, this cancels this, and we see that our pressure units then become kilogram per meter per second squared. We give this a special name. We call it a Pascal. So 1 kilogram per meter per second squared. That's the same thing as 1 Pascal, which is abbreviated like that. So, you know, a Pascal can also be seen as a Newton per meter squared. There are several unit conversions in pressure that you're going to need to be aware of, and they look like this. 1 Pascal, 101,325 pascals. That's the same thing as what we call 1 atmosphere of pressure. So air has a certain pressure that's associated with it. It fluctuates a little bit, but roughly speaking, the pressure of the air at sea level is about 1 atmosphere. That's going to be the same thing as 760 millimeters of mercury, which is the same thing as something called 760 torr, which is the same thing as 14.7 psi, which stands for pounds per square inch. And that's going to relate back to our unit of pressure. Remember, pressure is force over area. In the imperial system of units, force is in pounds, and the area, a type of area in the imperial units will be inches squared. So that gives you PSI, or pounds per inches squared. By the way, this is also equal to 1.01325 bar. So we see that a bar is very close to the same thing as an atmosphere. And you're going to need to get used to converting these units into one into another. Let's go ahead and do one of these conversions. Let's say I pump up my bicycle tires to a pressure of 135 psi. What is that in units of atmospheres? What's that going to be in units of millimeters mercury? So here's how you're going to do this particular problem. We know that 1 atmosphere is the same thing as 14.7 psi. So if I want to convert psi to atmosphere, I'm going to use this conversion factor. We also know that 1 atmosphere is going to be the same thing as 760 millimeters of mercury. So I can convert PSI into atmospheres first, and then convert atmospheres into millimeters of mercury. So I take my 135 PSI, put it over 1, use my conversion factor. I want to get rid of PSI and convert that to atmosphere. So because I want to get rid of PSI on the numerator, of course, I want to divide by that so that they'll cancel. And we'll convert to atmosphere. To do the conversion, we got to put in the appropriate numbers. 1 atmosphere is 14.7 PSI. We can run that calculation. 135 divided by 14.7, 9.18. So we see that 135 PSI is 9.18 atmospheres. Further converting into millimeters of mercury, I'll take my 9.18 atmospheres. And of course, using this conversion factor, 1 atmosphere is 760 millimeters of mercury. Converting the numerator to millimeters of mercury, 9.18 times 760 gives me 6,980 3 sig figs millimeters of mercury. We started with 3 significant figures, and both answers here are going to end with 3 significant figures. It's useful to note where some of these crazy units come from for pressure, like 1 atmosphere. That kind of makes sense that air has a pressure associated with it that we'll call an atmosphere. But why is this 760 millimeters of mercury? What's going on there? Well, there was a scientist named Torricelli who argued that we live in what he noted as a sea of air. In other words, what he argued was that just like when you feel a pressure when you go to different depths in water, we should also experience a pressure from the air as we go to different depths in air. And he showed this in the following way. He took a test tube that he filled all the way to the top with mercury. And we may begin to see where this unit's coming from. Nevertheless, this was filled all the way to the brim with mercury. And then he placed his thumb over the hole and inverted it and placed it into a pan that was also filled with mercury. So here's the inverted test tube. Mercury's in here, which is a liquid, and there's mercury in the column, the test tube as well. And what would happen is the mercury would fall to a certain level. So this is the level that the mercury liquid has fallen to. And when it falls, it would form a vacuum here in the headspace. But it would only fall to a certain point. And the argument is that obviously there's no gas in a vacuum, so there's no pressure here, but there is air pressure pushing down on the liquid mercury in the pan, which allows the mercury to rise in the column. And at sea level, the column of mercury tends to rise to the level of, you guessed it, 760 millimeters tall, which is about 76 centimeters, like 3/4 of a meter. Of course, when air pressure drops, then of course the level of the mercury drops, and as the pressure rises, the level of the mercury rises as well. And this was shown to occur as you move up in the atmosphere. As you move up in elevation or up in the atmosphere, of course, your pressure is going to drop. And as you move down in the atmosphere closer to sea level, the pressure is going to rise. And so that's where this unit comes from.